Welcome back to Environmental Economics. Today we're finishing up our chapter on risk and harm, and we ended the last lecture with a question, which is what might be wrong with characterizing risks by these two features, these two arguments, one of which being outcomes, the state of the world, and one of which being probabilities, the chances we see those outcomes. So I hope you all came up with some unique and clever answers on your own. But there are two in particular that I was thinking of. One is we might not know the probabilities. So this is sort of always true. We never know with certainty a probability. We often have to guess. And sometimes our guesses are good and sometimes they're not so good. But the other is different people might value those outcomes and probabilities differently. So let's sort of see that in practice. When facing uncertain outcomes, when facing risky prospects, some people choose to maximize the expected value of those risky prospects. So you might be familiar with this notation, but expected value is the outcome of an event weighted by the probability it occurs. And you see that we'll add that up over all outcomes from 1 to k when there are k outcomes. You might be more comfortable seeing this in sum notation, the sum as I goes from 1 to k of the outcome I weighted by the probability outcome I occurs. What this measure, this expected value, is telling us is basically the average outcome. If the world were to play out these outcomes with these probabilities many, many times, here I have 1,000,000, but you can think of, a billion or a trillion or just some very large number, large n. On average, what will we get each term? And we can think about this in environmental economics terms. We can think about it in terms of cost-benefit analysis. Suppose that we are conducting a CBA with a large project. That project pays $750,000 in benefits, but there's a small chance, a 1% chance, that the project destroys a huge wetland that has a value of $50 million. The expected value of the project, in that case, is $750,000, but the expected value of wetland loss is $500,000. In that case, we are maximizing expected value by undertaking the project. By this rule, we should conduct this project. We should commit to this undertaking. And people who are choosing to maximize their expected value are described by economists as risk-neutral parties. But note that not everyone is risk-neutral. So on your own, take a minute to think about why that might be the case. And the answer is that some people aren't risk-neutral. In fact, arguably most people are what we call risk-averse. This means they're willing to sacrifice some amount of expected value in order to gain security. And by security, we mean a reduction in risk, a reduction in the variability of the outcome. If these people, these risk-averse people, are willing to sacrifice expected value in order to gain security, we can think about that in reverse as well, which is in order to take on uncertainty, in order to take on variability in the outcome, they must be compensated. We need to pay them some sort of risk premium in order to take on this uncertainty. And because we think most people behave under risky situations this way, economists have a way of representing their decision-making. That representation you might be familiar with is expected utility theory, or EUT. And instead of probability weighting outcomes in expected utility theory, we probability weight the utility of those outcomes. So it's very similar to expected value, but differ in that we plug everything through this black box, this utility function. And because we tend to think that marginal utility diminishes, because of this feature of diminishing marginal utility, large reward, very good outcomes have smaller effects that are proportional to the size of the award. In other words, if your utility function is curved and concave, by the time we get out to these very large x, we're not adding that much utility each time. Marginal utility is diminishing, which suggests that this risk-averse person prefers certain income to a gamble with the same expected income. We can represent this concept, this expected utility concept, mathematically very similar to our expected value function, where the equation for expected utility looks like the utility of a certain outcome weighted by the probability of that outcome added up over all outcomes to the kth outcome. So if we have k outcomes going from 1 to k, we sum up the probability of that outcome weighted by the utility associated with that outcome. You might be more comfortable putting this in sum notation. The sum of outcomes I, as I goes from 1 to k, of the utility of an outcome weighted by the probability of outcome I. But like we mentioned in the last lecture, environmental economics is not particularly well suited to deal with some of these uncertain outcomes, even if we have a well-defined utility function. So on your own, think about ways we can go further to evaluate how people feel about these risks. And the answer is really a question for behavioral economists, which to some extent is beyond the scope of this class. But there are many behavioral theories for how people fare, how people address risk preference. Going from the bottom up, one very famous one is prospect theory, which in turn suggests that people have loss aversion, that people feel differently about losses as they do to corresponding gains. So we can imagine ourselves in this case. Suppose I'm, some happy guy because I have $5. Now, if you come along and give me another $5, I'll like that a lot. But that might not be the only uncertain outcome that happens. Suppose you come along and take my $5. Let me switch to a red pen. Suppose you take my $5. I'm going to be very unhappy. And in particular, what loss aversion says is my unhappiness in this situation, when you take my $5, is much larger, much more severe than my corresponding happiness when you give me $5. So we'll say plus 5 is a little smiley face, minus 5 is a big, mean smiley face, frowny face. What these theories say, prospect theory and loss aversion, are saying is that people might be behaving irrationally. But it's really important to note that in environmental economics, we're not talking about you or me or our friend down the street, but we're really talking about society's value for risk overall. And so we really need to know whether people are behaving rationally so that when we aggregate up to the societal level, our numbers, our estimates, our cost-benefit analyses continue to make sense. Now, we started this lecture by saying all this depends on us having those probabilities well defined and well estimated. But in many cases, those estimates are just our best guesses and we don't really know. We typically work from estimates where our probabilities are subjective. And in that case, especially when we're doing things like conducting cost-benefit analysis, it's best to test a range of probabilities, especially if we're more and more uncertain. We have a few more concepts in valuing risk, so I'll put risk value here. One is option value, which is the value to keep open an option that may not be valuable instead of taking an irreversible step. So what do we mean by this? When we make choices strategically, we close other options off. So when you signed up to take this class, you were, by definition, not signing up to take another class that meets in the same time period. Alternatively, you could have delayed your registration, leaving both options open. But that might have had some downside risk associated with it. So on your own, take a minute to think of some sort of option value example. The one I came up with is, suppose there's some undiscovered species in the rainforest. We know that there's a lot of benefits to a lot of new species. Perhaps this undiscovered species has the potential to cure cancer. If we cut down the rainforest, we cannot recoup that upside potential of this species that may or may not exist. But it's important to note that costly investments are also irreversible. So earlier I gave the example of building a seawall outside New Orleans. Note that option value does not have a set direction. It doesn't need to push us towards pro-environment actions. The other concept in valuing risk is endogenous risk. And when we say endogenous, we mean determined within the system. I think this is a topic that's relevant to a lot of what you all have been bringing up in classroom discussions, which is the amount of risk that we're exposed to is influenced by the choices we make about how much risk to take. If I choose to have a risky job, I might also have risky home and risky recreation. For instance, because I chose to teach here at Sweetbriar, I might also be exposing myself to risk from wildlife or poison ivy or something similar. This is important because people respond to risk behaviorally. So we need to understand these aversion behaviors and the human response to risk in order to value the potential damage that exists out there. And since different people have different abilities to engage in these risks, the impact of this endogenous risk might be unequal. Finally, we can talk about not just valuing risk, but managing risk. So we can talk about portfolio risk, or in other words, diversification, where you reduce your total risk by having your eggs in more than one basket, as it were. Not everything you bet on is likely to fail. This only works, of course, if we're diversifying things across uncorrelated risks, or risks that are negatively correlated with each other. For instance, if we have pocket ecosystems or species separated from each other, we can preserve some ecosystem services even if some species are lost. To bring this back to our conception of risk, some people say that even though we are by nature risk averse, if society makes investment decisions in a risk neutral way, we'll be protected against a bunch of different projects just by virtue of diversification. One strategy in this form of diversification is hedging. So compensating for risks in other investments. In the Engel piece we read before class, green energy is a hedge against negative impacts of climate change. Finally, the last way to manage risk, certainly there's more than these two, but the last way we're going to talk about is insurance, where we pay a set amount, a premium, and the insurance company bears the downside risk for us. If the bad thing happens, we get paid or compensated. If the good thing happens, we're in the good state of the world. We'll note that because we're paying this insurance premium, insurance does not, on average, reduce anyone's costs, because the insurer will not do something that loses itself money on average. It just shifts the risk from someone to the insurance company. Why are they willing to do this? Because insurance companies are diversified. They have a large portfolio of entities they're insuring, a whole pool of entities, so they likely won't experience all these bad outcomes at once. Which is a great way to manage risk, but unfortunately cannot really solve most risks related to the environment, where we might be talking about these catastrophic risk levels. That's all for this time. I look forward to talking to you next time when our topic will be natural resources.